So first we have to check whether it is maximization or minimization problem. So here, these are the corner points we got. Using this corner point, we can find the optimum value. You have to find the maximum point here. So which is a maximum here? So 24 is a maximum point. So 40.6 is a maximum value. It comes under the point called x1 is equal to, in first constraint we have negative value, and here also we have minus x1 plus x2 is equal to 0. Hello everyone, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram College, Mysuru. In my last session, I have discussed LPP by graphical method. So what are the steps we have to use for constructing a graphical method? So first we have to formulate the problem, and next we have to construct the constraint lines, and we have to plot the objective function, and we can identify the feasible region. So using LPP model, we can construct a graphical method. So let's get started. Today I will discuss LPP by graphical method. First problem is solve the following LPP by graphical method. So here we have a LP method. So using this LPP method, we can solve a graphical problem. So first we have to check whether it is maximization or minimization problem. So here we have max z is equal to 2x1 plus 5x2. We have two decision variables called x1 and x2. This is called as objective function, and subject to constraint we have three constraints. So first we have to change all the constraints value to equations. So first step is change all the inequalities to equalities. So first I will change the inequalities into equalities. x1 plus 4x2 is equal to 24. So it's in inequality in the sense less than or equal to, greater than or equal to. So here I have changed this inequality into equality. This is my equation number 1. And the second equation is 3x1 plus x2 is equal to 21, equation number 2. Change inequality into equality. And the third equation is x1 plus x2 is equal to 9, equation number 3. Have changed into standard form. So this is standard form. All the inequalities, you have to change it into equality. So here we have three equations. So using these equations, we can find the constraint points. So how to find the constraint? So first I will take the first equation. x1 plus 4x2 is equal to 24. So here you have to substitute the value of x1 and x2 for finding the point. Put x1 is equal to 0. If x1 is equal to 0, 4x2 is equal to 24, x2 is equal to 6. So now first point is 0 and the second point is 6. So first a of 0 comma 6. First point is a of 0 comma 6. And put x2 is equal to 0 to this equation. Put x2 is equal to 0. So x1 is equal to 24. So now the second region is 24 comma 0. So here we got 2 points, a of 0 comma 6 and b of 24 comma 0. And the second equation is 3x1 plus x2 is equal to 21. So first step is put x1 is equal to 0. If x1 is equal to 0, 3 into 0 is 0. So x2 is equal to 21. The third point is 0 comma 21. And put x2 is equal to 0. If x2 is equal to 0, 3x1 is equal to 21. x1 is equal to 21 by 3. So x1 is equal to 7. The region is 7, 0. So this is point D. 7, 0. And the third equation is x1 plus x2 is equal to 9. This is equation number 3. So put x1 is equal to 0. So x2 is equal to 9. So fifth region is 0, 9. And put x2 is equal to 0 and x1 is equal to 9. And the sixth region is 9, 0. So using these equations, we can find the region points. So here we have 6 regions. A of 0, 6, B of 24, 0 and C of 0, 21 and D of 7, 0, E of 0, 9 and F of 9, 0. So using these points, we can find the constraint lines. So how to find the constraint lines using graph sheet? So here I will find the x-axis and y-axis. So this is x-axis and this is y-axis. This is the region called 0. So after this, you have to mark all the points. So first point is A of 0, 6. This is 0, 6. First point. And the second point is 24, 0. Here 24 is here. 24, 0. Second point. So using these 2 points, you can join a constraint line. So first constraint. And third point is C of 0, 21. 0 and 21 is here. 0, 21. And the fourth one, we have 7, 0. 7. This is 7. 7, 0. So join these 2 lines. Have joined 2 constraint lines. So this is first constraint and this is second constraint line. And again we have 2 more points. E of 0, 9. 0 and 9. 0, 9. And the last one we have 9, 0. This is 9, 0. You just connect these 2 lines. So now have connected 3 constraint lines. So this is the third constraint. So for connecting all the constraint line, we'll get the common region, that is feasible region. So here I have to find the feasible region. So this is the common point. So below the constraint, have to shade only this region, because in this I have got the corner point. So this is my feasible region towards the region. Towards the region means that is below the constraints. We got 5 corner points here. 1, 2, 3, 4 and 5. So now find the corner point. So first I will take, this is A, 0, 0 and this is B, that is 0, 6 and the third one called C. C means it is 5, this region is 5 and this is also 5. So 5, 5 and the D region is 2.8 and 2.8 and 7. 2.8 comma 7, and the fifth point is E, that is 8 comma, and the last one we have, this is 7 comma, this is 2.8, and the last point, this is E of 7 comma 0. So these are the corner points we got. So in your graph sheet, you have to find the region. In graph sheet, you can find out the point value properly. So these are the corner points we got. Using this corner point, we can find the optimum value, maximum optimum value. So first corner point is 0 comma 0. A of 0 comma 0. For this objective function, we have to substitute all the corner points. So first one is 0 comma 0. x1 is equal to 0 and x2 is equal to 0. So 2 into 0 plus 5 into 0 is equal to 0. And point B is 0 comma 6. So x1 is equal to 0. 2 into 0 plus 5 into 6. It is 30. And the third region is 5 comma 5. C of 5 comma 5, it is 2 into 5 plus 5 into 5. 10 plus 25, it is 35. And the last and the fourth region is 2.8 comma 7. 2.8 comma 7. Substitute the values. 2 into 2.8 plus 5 into 7. So 2 into 2.8 is 5.6 plus 35. So 35 plus 5.6 is 40.6. And the last region is 7 comma 0. E of 7 comma 0. Substitute the values. 2 into 7 plus 5 into 0. So it is 14. So out of these values, so which is a maximum value here? So 40.6 is a maximum value. It comes under the point called x1 is equal to 2.8 and x2 is equal to 7. So max z is equal to 2x1 plus 5x2. So maximum value is 40.6. This is a maximum value, comes under point 2.8 and 7. So if you get any confusion on this point, so you can substitute the value of x1 and the value of x2. So you'll get the same value. So this is your final answer. So z is equal to 40.6 at the point value called 2.8 and 7. So the corner point D is a maximum value. So the given LPP has a solution. And next we'll see the second question. So here you have objective function and constraints again. So objective function is 2x1 plus 3x2. So first write it in a standard form. All the inequalities you need to convert it into equalities. So x1 plus x2 is equal to 30. This is equation number 1. And x2 is equal to 12 and x1 is equal to 20. So here you don't have x1 and here you don't have x2. So but this is an equation. So first put x1 is equal to 0. x1 is equal to 0 means x2 is equal to 30. So point A is 0 comma 30. And put x2 is equal to 0. So x1 is equal to 30. So point B is 30 comma 0. So we got 2 points. And the third point C is, so in second equation we don't have x1 value. So x2 is equal to 12 only. and in third equation x1 is equal to 20. So using this points A and B and C and D, we can construct a graph. This is x-axis and this is y-axis and the region is 0. So here find the maximum value. So 30 is the maximum value here. So I will find the scale 10, 20, 30, 40 and 50. Again 10, 20, 30, 40, 50. So scale 1 unit is equal to 10 centimeter. First connect this point 0, 30. This is 0 and this is 30. 0, 30 and 30, 0. 30, 0. And x2 is equal to 12 means, so y is equal to 12. So this is the region 12. So first connect these 2 points and x2 is equal to 12 means this is x2 12 value and x1 is equal to 20. So this is 20. So here you got one constraint, first constraint, second and third constraint. So now you can find out the corner point and feasible region. So here 2 points are connected each other. So this is one feasible point and this is a feasible point. So here I will find the corner point. So this is my corner point and this is my corner point. I have 5 corner points. So this below the constraint means this area. So this area is called as feasible region. So I will share this feasible area. So here I got 5 corner points. So which are the corner points? This is A, 0, 0 and B is 12, 0, 12, 0 and C is 15, 12, 15, 12 and again 20, 11. D is 20, 11 and 20, 0. So these are the corner points. So first find the corner points and you can find the optimum solution. So here we got 5 corner points. Using this corner point we can find the maximum value. So first corner point is 0, 0. So 0, 0 means it is 0 only. So 12, 0. Second point is 12, 0. Substitute the values. 2 into 12 plus 3 into 0. 24. And the third one we have 15, 12. 2 into 15 plus 3 into 12. 30, 36. 66. And the fourth one we have 20 and 11. 2 into 20 plus 3 into 11. 40 plus 33 is 73. And the last one 20, 0. 2 into 20 plus 3 into 0 is 40. So out of these points, which are the maximum value? Maximum value is 73. So max z is equal to, the maximum value is 73. It comes under the point called x1 is equal to 20 and x2 is equal to 11. So hence this problem has a solution. And the next problem is solve the LPP by graphical method. So 3x1 plus 4x2. We have objective function. Please convert this inequality into equality. So x1 minus x2 is equal to minus 1. We have negative value. And x1 minus x1 plus x2 is equal to 0. So here we have 2 constraints. In first constraint we have negative value and here also we have minus x1 plus x2 is equal to 0. So now I will find the point values. So put x1 is equal to 0, minus x2 is equal to minus 1. So x2 is equal to 1. Minus minus get cancelled. So x2 is equal to 1. So point A is 0, 1. 0, 1. And put x2 is equal to 1. So x1 is equal to minus 1. So point B is minus 1, 0. So minus 1, 0. And put x2 is equal to 0. x2 is equal to 0 means x1 is equal to minus 1. And point B is minus 1, 0. And the second equation, put x1 is equal to 0 and x2 is equal to 0. So point C is 0, 0. And put x2 is equal to 0. So x1 minus x1 is equal to 0. x1 is equal to 0. Point D also 0, 0. So here we got 4 points. So here point B has minus value, negative value. So I will use for this minus negative value, I will use another quadrant. This is the region 0. This is x-axis and y-axis. So I will take the scale 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And here I will take minus 1, minus 2, minus 3 and minus 4. Minus 1, minus 2, minus 3. So first point is 0, 1. 0, 1. And the second point is minus 1, 0. So minus 1, 0. I will join this 0, 1 and minus 1, 0. And the next point is 0, 0 and 0, 0 only. 0, 0 and 0, 0. I'll draw this. So here, do we have any common region or common point for getting the feasible region? So there is no feasible point. So it has a no solution. So this LPP problem has no solution because we didn't get any feasible point. So this is your graphical method. So you can find the scale value here. Scale 1 unit is equal to 1 centimeter. So we don't have any feasible point in this problem. So it has no solution. So this is your LPP problem. So in my next session, I will discuss some more problems on LPP. Thank you.